Okay, so right now we're working our way through Chapter 3, and Chapter 3 is all about learning derivative rules. And we're going to hit the power rule here. And just to sort of recap something that I did in Chapter 2 is suppose I've got a function that is x squared. And then by my definition of a derivative, f prime of x is going to be the limit as h approaches 0 of f of x plus h plus f of x divided by h. So I'm going to say that f of x plus h is going to be x plus h squared, and I'm going to write that out. I'm going to FOIL it out as x squared plus 2xh plus h squared. And so then I'm going to go x squared plus 2xh plus h squared minus x squared over h. And then that cancels, that cancels, that cancels, that cancels, that cancels. And you get 2x plus h, which is approximately equal to 2x. So I'm going to say that f of x equals x squared, f prime of x is equal to 2x. Okay, and we sort of fooled around with this, and we kind of tried some of these, and I sort of introduced to you already in previous videos that the power rule is going to be if you have f of x is equal to x to the n, then f prime of x is going to be n times x to the n minus 1. Okay? Now, so that's going to work with whole numbers. So if I've got y equals x cubed, then dy dx is equal to 3, move it up front, x to this 2, x squared. So I do take the 3, take the exponent, write it out front, and then my new exponent is 1 less than that. And so it's going to work for whole numbers. It's also going to work for 0. So I take the exponent out front, which is 0, and then I've got x to the negative 1, and so then x to the negative 1, that doesn't really matter. What really matters is that 0. So the derivative, so that okay, so that is sort of working our way backwards. This is a horizontal line. Y equals 5 is a horizontal line. Think about it. So what's the derivative? What's the slope of a horizontal line? Well, the slope of a horizontal line is 0. So what's the derivative of this function? Well, it's 0. And then this function is the same as that function because x to the 0 is just 1. So the derivative of that is 0. And so that ties into our constant multiple rule from my previous video, which I just sort of glossed over really quickly. Okay, so it works when the exponent is whole numbers, works when the exponent is 0. It also works, it just works for all exponents, basically. So I got y equals x to the negative 2. So that means that dy dx is equal to negative 2x to the negative 3. Now this is an important one because you're going to see this. Remember, another way to write this is to write it this way. And so beginning calculus students generally will botch how to take the derivative of this, because what they'll say, I'm not even going to write it down, I'll write it on a little scrap of paper here and then I'll make it go away. What they're going to say is that dy dx is equal to 1 over 2x. That's what they're going to say. Because, well, when you take the derivative of x squared, the derivative of x squared is 2x. So the derivative of 1 over x squared is 1 over 2x. No, I don't want to have that anywhere on there. So I'm ripping up the little sheet of paper and we're throwing it away. You have to write this as y equals x to the negative 2, and then write that as dy dx is equal to negative 2x to the negative 3. Okay, so that's how you're going to deal with the negative exponents, and if you've got positive exponents in the numerator. Okay, and we'll get more complicated as we go on. This is not a 1 hour course, this is a whole year course. Okay, next one I want to do is decimals. Decimals should work just fine. So y equals x to the 3.5. Well, that's just dy dx equals 3.5 x to the 2.5. I can do numbers less than 1, or I can do numbers between 0 and 1. I can do x to the 0.5, and that one gives me dy dx equals 0.5 x to the negative 0.5. Now, that leads us into fractions. So I want to look at this. This one is really, really important. So I'll squeeze 2 in here. Y equals x to the 1/2. dy dx is equal to 1/2 x to the negative 1/2. Okay, now x to the 1/2. What's another way of writing x to the 1/2? It's really, really critical that you understand how to write another way to write x to the 1/2. This, I don't like the squiggly, I don't like the square root sign. This is x to the 1/2. The square root of x is the same as x to the 1/2. Okay, so that means that this has the same thing. If these are the same, then this is the same. And so then I can rewrite that back in my squiggly notation. So, using my exponential rule, using my power rule, the derivative of the square root of x is equal to 1/2 times 1 over the square root of x. Okay, we're going to keep going with these, and we got a couple more just on that, and then we'll be done. So what I'm going to do now, just a few more examples, is let's do this one a few different ways. Okay, so y equals the square root of x to the 7th. Let's look at that one. Well, that is the same as x to the 7th to the 1/2, and that's the same as x to the 7/2. And so that's the same as x to the 3/2, or I'm sorry, 3.5. And so dy dx is equal to 3.5 x to the 2.5. So there's a lot of ways you could write it. We could just write it as 7/2 x 7/2 square root of x to the 5th. Doesn't really matter how you write it. The key thing is to understanding how our basic power rule just works without any problem. And next one I want to do. Y equals cube root of x. Okay. How are we going to write cube root as an exponent? You guys should hopefully know that. Hit pause if you need to figure out how to write cube root as an exponent. I'm going to write that as x to the 1/3. So that means that dy dx is going to be equal to 1/3 x to the negative 2/3. Because 1/3 minus 1 is negative 2/3. And then finally the last thing I'm going to do here is, well, let's do two more. Y equals square root of x to the 7th. But wait a second, come on, man. We just did this one before. These are the same thing. Whether I do x to the 7th power and take the square root of it, or whether I take the square root of x and raise it to the 7th power, it's all going to be the same thing. So I've done that one before. And then I'll just do one more, and then we're done. Okay, so we're going to write this. How are we going to write this as just an exponent? Sorry. Okay, I guess we're not done. There's one thing I just want to sort of say. Constant multiple rule. So our stupid constant multiple rule applies to all of this. So if I've got y equals 5 times the square root of x, that's going to be equal to dy dx is going to be equal to 5 times 1/2 x to the negative 1/2. Just constant multiple rule. We did this one right there. And all I'm doing is multiplying by 5. And then I can just string them all together with my addition and difference rules, sum and difference rules. So I can do 3x cubed minus 2x plus 1 over x minus x to the 5.7. Oh, let's make that a 9. And I'm going to just rewrite it. 3x cubed minus 2x plus 9 to the x to the negative 1 minus x to the 5.7. And so dy dx is equal to 9x squared minus 2 minus 9x to the negative 2 minus 5.7x to the 4.7. Okay, that's all I gotta say in this video.